Now we're going to talk about measures of dispersion. Measures of dispersion indicate the amount of spread or scatter about a central point. We're going to talk about three measures of dispersion. One is real simple, that's the range. The most complicated one is the variance. But here's the good news, if you can calculate the variance, the standard deviation is just a simple push of a button on the calculator. So let's go ahead and start with the range. The range is actually the difference between the largest value and the smallest value. So all you have to do to find the range is find the largest value. So let's look. The largest value I see in this data set is 5, and the smallest value that occurs is 2. So the range is simply 5 minus 2, which is 3. And then here, the largest value, ignore those that are bold, that's not supposed to be bold, but the largest value here is 92, and the smallest value is 63. So the range of this data set would be 92 minus 63, which is 23. So that's how simple the range is to find. One of the reasons we want to talk about dispersion is because you could have two data sets that have the same mean. Let's say you've got two sets of scores that have an average of 70, but on one set of scores the values are very close to 70, but on the other set of scores the values are very high or very low, but they still average 70. Well, that would tell us something different. So the score with the high and the low scores, the set of data with the high and the low scores, would have a large variance in standard deviation, whereas the data set with the scores that are close to the mean would have a smaller variance in standard deviation. So let's talk about how to find sample variance. I'm going to focus on sample variance because sample variance is generally what we're going to be looking for. Now, to find sample variance, what we do, here's the formula, but the formula can look a little complicated, but S squared stands for sample variance, and this sigma means that we sum, but what is it we sum? Well, xi would be your data value. So we take each data value, subtract the mean, and then square it for each of the data values. We have to do that for each data value, and then we add all of those values up. But that's not the last thing to do. The last thing you do is you divide by n minus 1. Now I gave you a set of steps here that you can read to see what to do. Now, the true population variance is actually different. And for some reason statisticians say if you want to find the sample variance, it's better to divide by n minus 1, even though the population variance is actually calculated the same way, except you divide by n. So again, let's do the sample variance first. So let's say I have these 5 scores, 18, 14, 17, 21, and 15. Now earlier I found that the mean is 17. So we already know the mean is 17. So I'm going to take each score, subtract the mean, and square it. So I take 18 minus 17 and square it. I take 14 minus 17 and square it. 17 minus 17 and square it. 21 minus 17 and square it. 15 minus 17 and square it. So each of these data scores, I'm going to subtract the mean, which is 17, and then square it. And then I'm going to divide all of that by n minus 1. Now remember, n is 5 here because we have 5 data values. So I'm going to subtract 1 from 5, and so I'm actually going to divide by 4. Now let's finish the numerator. 18 minus 17 squared is 1 squared. 14 minus 17 squared would be negative 3 squared. 17 minus 17, that would be 0 squared. 21 minus 17 squared is 4 squared. And then 15 minus 17 would be negative 2 squared. Now if we square each of those, we get 1, 9, 0, 6, 16, and 4. Add those up, and you're going to get 30, and then divide that by 4, and you're going to get 7.5. So the variance, and that should be S squared there, the variance is actually 7.5. Now, if you were going to calculate the population variance, then you would do exactly the same thing, except you would divide by 5. Instead of n minus 1, you actually would divide by n. So it's exactly the same, but you would divide by 5 instead of 4. Now, but this is a sample. So really, this would be like taking a sample from the population and calculating the sample variance. So what I did down here, it really wouldn't make much sense unless I took every value from the population and did this process with every value from the entire population. And by the way, this should be squared too. These are the variance, and they have to be, their variables that represent them are squared. So S squared is 7.5, sigma squared is 6. Now you can also use a table sometimes to find the variance. So let's find the sample and population variance from this table. So let's say from these 10 values. So now these are the same 10 test scores that I had earlier. And earlier I found that the mean was 78.2. So notice that I used 3 columns. You actually can just do 2 columns if you want to. But you can say 82 minus 78.2, then square it to get this. And of course you need a calculator to do this. 73 minus 78.2 squared gives me 27.04. 81 minus 78.2 squared gives me 7.84. And you do that for each data value till you get to the very end, and I got another 82. So 82 minus 78.2 squared again is 14.44. Well, then we add all of these up, and that's what this sum symbolism means here. We sum all of these squares, and we get 433.6. Now, if we're assuming this is a sample, we will actually divide by n minus 1, which is 9, and get 47.18. But if we are calculating population variance, we would divide by n, which is 10, and we would get 43.6. Now, once you have this, it's very simple to get the standard deviation. So if we want the sample standard deviation, we would take the square root of the sample variance. So take the square root of the sample variance, square root of 47.18. On the calculator, I got 6.87. If I want the population standard deviation, then I would take the square root of the population variance. So the square root of 43.6 is 6.6. So that's how you find the sample variance, population variance, and sample standard deviation, and population standard deviation. Let's take a look at another example. Let's say that we've got 5 basketball players, 72 inches, 73 inches, 76 inches, 76 inches, and 78 inches. The mean would be 75. Now, I'm just going to calculate the sample standard deviation here. So each x value, I got the mean already at 75. So I take each of these values, subtract the mean from it, and square it. And then I add these values together. 9 plus 4 plus 1 plus 1 plus 9, and I get 24. Then, since I'm getting sample variance, I divide by n minus 1, and 5 minus 1 is 4. Remember, I have 5 values, so 5 minus 1 is 4. Divide that into 24, the sum, and I get 6. And then to get the standard deviation of that, I just take the square root, which is 2.45. So it's a little bit complicated, but if you take it step by step, it's not too bad. Freeze the video here and then look at these practice problems and give them a try if you like. I've got the answers given. I'm going to finish up, show you how to calculate some statistics from grouped data samples. We might have class intervals, say for instance 3 to 7, 7 to 11, 11 to 15, and 15 to 19. Well, and also the frequency. So in other words, this means you have 4 values that fall in this range, 2 values that fall in this range, 1 value in this range, and 3 values in this range. Now since I don't know what those values are, what I'm going to do is just find the midpoint. So I'll find the midpoint of this class interval, 3 plus 7, which is 10, and then divide it by 2 to get the midpoint, 5. And then so I add 7 plus 11, which is 18, then divide it by 2 to get the midpoint, which is 9. And then 11 plus 15 is 26, divided by 2 gives me the midpoint, 13. And then add these two together and get 34, divide by 2 I get 17. So even though we don't know what these 10 values are, we know there's 10 values because if you add 4 plus 2 plus 1 plus 3, you get 10 for n. Now, but basically, I'm just going to assume that there are 4 5s, there's 2 9s, there's 1 13, and there's 3 17s. So, if I were going to add all these up, well, you could add 5 4 times, 9 twice, 13 once, 17 3 times, or you could say, well, if there's 4 5s, 4 times 5 is 20. If there's 2 9s, 2 times 9 is 18. 1 13 is just 13. And then 3 17s is 51. And then you could add them up, and what you're doing is you're adding up the product of each data value times its frequency. So it's called the XI-FI. So what you're doing is you're summing the product of XI times FI. And when you add these up, you get 102, and then all you have to do is divide this by 10, and once you divide that by 10, you get 10.2. And that's how you find the mean from a set of grouped data. Okay, here's another set of values. I actually gave you the data sets and I just made up some class intervals here. Between 2.5 and 6.5 there are 4 values. Between 6.5 and 10.5 there's 2 values. Between 10.5 and 14.5 there are 4 values. So if you add 2.5 to 6.5 and divide by 2, you get 4.5. If you add 6.5 to 10.5 divide by 2, you get 8.5. And if you add 10.5 to 14.5 and divide by 2, you get 12.5. Well, then you multiply these times their corresponding frequency. 4 times 4.5, 2 times 8.5, 4 times 12.5. And you get these 3 numbers. Then you add those 3 numbers up, get 85. And then to get the mean, you simply divide 85 by 10, and your mean is 85, or 8.5. Here's a practice problem that you can look at, and then you can freeze the video and then try to work it yourself. I'm going to just do one example for variance and standard deviation on group data, and then you can look at the lecture notes for the rest. These are the formulas for sample variance and population variance using group data. Notice the frequency comes involved, and you'll see that when I do this example. Okay, so in this example, we have the same frequency as before, we have the same midpoints as before, but remember the mean was 10.2. So what we do is we take each data value and subtract 10.2 and square it. So we take each value, subtract 10.2 and square it. Then we multiply each one of those values times the frequency, which was over here. So we multiply by 4 here, 2 here, 1 here, and 3 here. And these are the values we get. Now, we add those values up, and that gives us the sum of those differences squared times the frequency. And then you add those up, and remember, for sample, you divide by 10 minus 1. So we divide that by 9, and we get 28.62. And that's your sample variance. And then you take the square root of that for sample standard deviation. If you wanted population variance, of course, you would divide that number by 10 and then take the square root of that for population standard deviation. I'm going to leave you with this last example, and I'm going to slowly scroll through it so you can give this one a try. The first part of it, I'm calculating the mean, and then the last part of it, I'm going to calculate the variance and standard deviation, and then at the end there's a little practice problem that you can try if you like.